Hello everyone, my name is Zahra Ameli and I'm a PhD student in Civil and Environmental Engineering Department of the University of Maine, and my advisor is Professor Eric Landis. Today we are going to discuss briefly the UAV applications in bridge inspection. As we all know, failure of important infrastructures such as bridges can always be sudden and devastating. For example, in 1967, a failure of an eye-bar in a pin connection of a bridge caused the 40-year-old Silver Bridge to suddenly collapse, and this resulted in a loss of 46 lives. This tragedy led to approval of National Bridge Inspection Standard in the following year, and the standard is adopted in 1971, which specifies how frequency and by whom bridge inspections should be completed. For example, National Bridge Inspection Standards specifies two-year intervals for routine bridge inspection. According to the Federal Highway Administration database, about 7% of bridges in the United States and 13% of bridges in the state of Maine are in the poor condition. And monitoring these bridges and preventive maintenance requires a lot of time and effort. The conventional bridge inspection is a physical inspection which brings several limitations in practice, such as traffic closures, safety risks to the inspectors and public, and accessibility issues. For example, for difficult to reach areas of the bridge, the inspectors have to use under-bridge inspection trucks. To bring inspectors within arm's reach of bridge elements according to the requirement of Federal Highway Administration and AASHTO. And this might be dangerous for the inspectors. So on the other hand, using unmanned aerial vehicles or UAV has lately gained interest among bridge inspectors. UAV assisted structural inspections can address some of these limitations by providing safer, cost-effective, and efficient results. UAVs provide unique capabilities, including the ability to fly close to the areas of the bridge which are hard to access, and they can carry high-resolution cameras and sensors to overcome current bridge inspection limitations. So based on this information, many state DOTs are using or planning to use UAVs for their bridge inspection program. The states which are shown in blue in this map are states which are using UAVs specifically for bridge inspections. Some of these states have conducted very limited study on the application of UAVs for a bridge inspection, but some of them, like Minnesota DOT, conducted very comprehensive study on the application of UAVs. Minnesota DOT conducted three-phase study to detect concrete delamination using infrared sensors. And also they tried to efficiently document deficiencies and communicate this information with inspectors. However, all of these studies only use the obtained images to aid the inspectors by providing eyes in the sky without locating, quantifying, or measuring damage. So the bridge condition assessment is still largely relies on the manual inspection of the obtained images by inspectors without the aid of any in-depth data analytics tools. There are based on this information, there are several research areas which we can focus to improve UAV-based bridge inspection. And we perform comprehensive literature review to find out which of these areas would be more beneficial for specifically state of Maine. One of the first consideration in UAV-based bridge inspection is proper selection of the drones and UAV. And this selection should be done based on several considerations. For example, type of the mission to be completed, type of data to be collected, and type of the bridge to be inspected. And other research area is automated flight path planning, especially in the GPS denied environment, because GPS signals is not available everywhere, and it will be degraded or fully not available in underbridge areas or over border. Researchers evolved methods to handle the UAV navigation in GPS denied environment by using vision-based navigation, such as visual odometry and simultaneous localization and mapping. Next area is processing the collected images. Based on the many factors, there are hundreds or thousands of images which are collected by UAVs, and manual identification of flows in such large image set is time consuming and could be inaccurate due to human errors. So over the last decade, a body of scholars proposed various algorithms to automatically detect cracks or any other defects on the bridge surfaces. However, most of the popular methods can only address specific crack detection problems. Future-based and edge-based approaches separate an image into small blocks and then identify cracks by matching the small blocks with predefined features, where the crack features have to be defined very clearly and accurately, because the performance of these algorithms are strongly dependent on the predefined features. Currently, the most promising method for fully automated image-based defect detection is convolutional neural network. So we used convolutional neural network to image-based automated detection of concrete surface cracks. We chose two pre-trained architectures named AlexNet and VGG16 and performed these architectures on a database which is a large number of images collected by UAV of several bridges. And finally, we judged the performance of two architectures using several factors such as accuracy, precision, recall, and F1 score. So the next step is mapping the detected defects onto the 3D point cloud to obtain location and size information in real world coordinates, and also rating the bridge elements and the whole structural condition according to the Federal Highway Administration's bridge inspection reference manual requirements. Thank you for your time.